Hello, everyone. Hello, Passivhaus friends. Today, I want to talk to you about indoor air quality because I think this is such an important topic, and I think not many of us are paying enough attention about the indoor air quality in their homes, in their offices, or in any other places that they spend so much time in. So for that, let me share a little presentation with you. Okay, so let us talk a little bit about indoor air quality. And the first thing we need to understand is why buildings are so impactful in relation to indoor air quality. And that is because we are spending the majority of our time indoors. About 90% of our times we're spending indoors. That's 21.5 hours. About 33% in your bedroom, 33% at work. That for a lot of us is also an indoor environment. Maybe not your home, maybe your office, but still an indoor environment, and 25% with others. I always thought this is not quite true for me, but if I think about it, that I work at home, that I sleep at home, that I watch TV and cook at home, it could very well be true that I only spend 10% of my time outdoors. And if I want to achieve that 10%, I would have to spend 2.5 hours outdoors every single day. And I think even some days I may not achieve that. So that's the problem here. The indoor environment is not our natural habitat, and that has a health impact. So that's why it is so important to talk about health and comfort in your indoor environment. And that's what we want to address today, and we want to see where that leads us. So let's talk a little bit about survival for now. So how long can you survive without food? Yeah, 30 days. 30 days you can survive without food. How long can we survive without water? Think about it. How long could that be? It's 3 days. 3 days we have if we don't have water. Now, the next one is, how long could we survive without shelter? And that's only 3 hours. So keep that in mind the next time you go for your bushwalk or out in the wilderness. 3 hours is all you have. For sure, this is in a harsh environment. So if we're going on Mount Everest without our proper gear, or into a blizzard, or into a really hot desert without protection, then 3 hours is all we have. Still keep that in mind, that we are vulnerable in this environment. Now, the last one is, how long can we survive without air? And that's only 3 minutes. So 3 minutes is all we have without air. And this is, we are taking in so much air into our lungs, 7 to 8 liters per minute. That's 450 liters per hour. That equals 11,000 liters per day, 78,000 liters per week, and about 4 million liters per year. And all that air that we're taking in and whatever is contained in that air has a big impact on our bodies. And that's why it is so important to look after your air quality in your homes and in your indoor environment. To make that a little bit clearer, I want to share a video with you that was made by Velux.
In 160 seconds, you will decide how this story ends. This is a story about us, the indoor generation. A generation that spends 90% of its life indoors. It all started the day we left nature behind. We filled our homes with lovely things and all the stuff we wanted. Our homes became places you would never want to leave. Artificial light replaced daylight, and we built our houses so that nothing could escape. We cooked and showered, breathed and played, slept and sweated. But we had closed ourselves in to a point where nothing could get out. So when the air turned bad inside, we tried fixing it with chemicals. And we put in little artificial suns everywhere to make the darkness bearable. That's when things started to happen. Hard to notice in the beginning. Some needed help to sleep, to breathe, to not itch. Many of us even started to feel sad. So we turned on happy lamps to make the sadness go away. Then, scientists discovered that the air inside our homes is up to 5 times more polluted than the air outside, and that the lack of daylight can affect children's learning and increase blood pressure. It turns out that kids' rooms often have the highest concentration of toxicants in the house. In fact, millions of homes are unhealthy to live in. They discovered that living in damp and moldy homes increases the risk of asthma by 40%. And I learned that millions of people like me suffer from asthma and allergies caused by a bad indoor environment. And so, here we are. How the story ends is up to you, because it's not written yet. If you care about the indoor generation, do something. Begin to think and live differently. Let light and fresh air into your life again. Even small changes can make a huge difference for coming generations. Learn how at theindoorgeneration.com.
Wow, what a powerful video. So I think you can see now what I mean and why I'm so passionate about this topic. So the key facts to take away from this video is that we spend so much time, about 90% of our time indoors, that we have closed ourselves in until nothing can escape. And when the bad air turns bad inside, we use chemicals to try and make it better, to try and work against that. Also, the indoor air is often 5 times more polluted than the outdoor air, and the kids' rooms have the highest level of toxicants. So imagine that kids that are in their developmental phase where their brains still need so much oxygen to develop, we're putting them into that risk with so many toxicants. Also, moldy and damp homes have a 40% higher risk of asthma, and the conclusion is that we want to let fresh air into our building. Now, the question that comes out of that is, how do we get fresh air into the building? And that's what I want to answer and discuss with you now. How do we get that fresh air that we so desperately need into our homes, into our indoor environment, so that we can live healthily in there? So the first question for that we have to answer is, how much fresh air do we actually need? What would be considered a healthy and fresh air inside our homes? So we can look here at classification of indoor air qualities, and there's different indoor air qualities, 1, 2, 3, and 4, and they relate to a level of CO2 in our indoor environment, and this is what we have. So our outdoor environment is currently just above the 400 parts per million of CO2, and this would be a really good indoor air quality. But what Passivhaus is saying is that we are requiring a CO2 level of below 1,000 parts per million. That is still considered a very good indoor air quality. And indoor air quality, so the reason why Passivhaus has settled for this indoor air quality level is that indoor air quality 1 and 2, the airflow rate would be too high, and then we are risking dry air conditions inside our homes in winter. Yeah, so that's why they deemed this too high, and they've settled for this indoor air quality 3, which is still a really good indoor air quality for a healthy living. So Passivhaus standard has set now 30 cubic meters per hour per person as the amount of fresh air for good indoor air quality. So we need to remember that, and that's one of the things that we need to know before we see how we want to deliver that into our rooms. So this is now, we know now how much we need. But how could we deliver that into the rooms? Or what does that mean, that 30 cubic meters per hour per person? What would we have to do to achieve this fresh air in our homes? For that, I want to show you here a little example of a bedroom that is a 20 square meter bedroom. And we're saying for making it easy, we say this has a 3-meter ceiling height. So we are looking at 60 cubic meters as the volume of air that's contained within this bedroom. Now, if we're saying that we're needing 30 cubic meters per hour per person as fresh air, then in this 20 square meter bedroom with 60 cubic meters of air volume, if we have one person sleeping in here, we say that we need now to open our window every 2 hours and exchange all the air inside to get that 30 cubic meters per hour per person of fresh air into our room. So that means you're sleeping in here every 2 hours, you have to set your alarm, get up, open the window for 10 or 15 minutes, and then get back to sleep again. I wouldn't call that a very restful night. Now, if we had 2 people in that room, we already have to get up every hour because now we need double the amount of fresh air because it's per person. Now, every hour we would need to get up and exchange that air in our room. At least now you could swap with your partner, but you would still probably hear the alarm going off every hour. And if we had a smaller bedroom, because this is quite a spacious bedroom, if we had half that size, so a 10 square meter bedroom with 2 people in there, then we would have to get up every 30 minutes. And you can already see that doesn't really work. So question is, what is the better approach? Is that incidental ventilation or controlled ventilation? And you can think about that a little bit while I tell you a little bit of the background of how we can ventilate our homes. So let's look at ventilation using natural forces. So natural forces, what we've just looked at, so by opening your windows, that would be using the natural forces. The problem with that is that natural forces are not always available and they change in their intensity. Yeah, so to have an air exchange happening, we need a pressure difference that can be created either by a temperature difference, or if you have wind, or if you have a height difference, then pressure difference exists and then air would exchange. You probably all had these days where it was really hot and stuffy, you opened your window and nothing happened, no air exchange, and that can happen. So nothing, sometimes the air just doesn't exchange. And so that makes it really hard to use the natural forces, and they also need constant management by the user so that we have the right amount of air in our indoor environment. Also, getting the desired amount of air into the right places is hard because you might have one room with good access of air, with a good cross ventilation. You might have other rooms where that's not the case. And most of the time that management is down to the user and not automated. So the user behavior has now a big negative, or can have a big negative impact. For example, someone leaving that window open all day on a really hot day. Now the heat is inside and now we need energy to cool it down again. And obviously also heat recovery and moisture recovery is not achievable, and the air that's coming into our indoor environment is not filtered. So any pollutions that are outside, we're getting into our indoor environment. Now, what could be the solution? Yeah, if we not wanna, or if we can't rely on our natural forces, the solution is a ventilation system where we're using mechanical forces to ventilate. The mechanical force is usually created by electricity. That is constantly available and can be adjusted if needed. And it can also be very easily automated. And every room now gets this designed amount of fresh air with our ventilation system. The other advantage, big advantage, is that heat recovery and moisture recovery are now possible. So what that means is that the energy that we have in our building doesn't get lost. It's not getting thrown out of the window, but we're recovering that heat. We're separating the indoor environment from the outdoor environment. We can do the same with our moisture, and we're not losing that energy. And plus, we're having filter in our ventilation system so that all the pollens and dust and everything that's in the outdoors will get filtered out, and we're getting really fresh, clean air into our indoor environment. Now, you might ask yourself, oh, but this is operated by electricity. Now we're using energy to supply our air. But the energy consumption for these units are really, really low, usually far less than what we're gaining by the heat recovery that this machine does. So how does mechanical ventilation work? Okay, so we are supplying fresh air to all our habitable rooms. A habitable room would be one where we spend a lot of time in. That would be our lounge room, dining room, offices, bedrooms. All of those get fresh air supplied. And then we're extracting our stale air from kitchens and bathrooms and all other rooms where we produce moisture or odor. So it's a really good cycle. It's a really good cross ventilation, and all the parts of the house get ventilated properly. The fresh air that's coming in is pre-warmed or pre-cooled via the heat exchanger. So the heat exchanger is making sure that the air is not coming in at outdoor conditions, but it's coming in pre-conditioned. So that we don't have to spend all that energy on heating or cooling the air from the outside again. And these days, these ventilation systems are so good that up to 96% of heat recovery efficiency is possible. So we are really keeping most of our energy inside, and we have always got fresh air available in our indoor environment. So this is the solution to having fresh air, so an indoor air quality where we have no health risks. So as a little reminder or a little background, if you don't know about Passivhaus yet, we always want to reach a thermal comfort zone in a Passivhaus of 20 to 25 degrees and a relative humidity range between 30 and 60%. So that's for our comfort. But on top of that, as I've just talked about it, we want to have this sufficient design airflow rate where we keep our carbon dioxide levels below 1,000 parts per million. And we're using filters for our outdoor air. Yeah, so filtering out all the particles that are unwanted. For a bushfire situation, we may need even a better filter, but even that can be achieved. And we need another filter for our extract air to protect the unit so that it's not contaminated, that we're not creating any mold or any dust or anything in the system that could then pollute our indoor air. So let's recap a little bit. What are our air quality requirements? So because we spend 90% of our time indoors, we want to make sure that our indoor air quality is good and has no health risks. For that, we need to provide 30 cubic meters per hour per person of fresh air. And we want to have that sufficiently filtered. We want to deliver that via an HRV system because we've seen that the natural forces are not reliable. And we need an HRV system to provide us with that amount of air. Now, having said that, just as a little side note, it doesn't mean that you can't open a window in a Passivhaus. That's not true either. You can always open a window in a Passivhaus as well. So if the outdoor environment is in favor of your indoor environment, open up, yeah, let the air in, beautiful, hear the birds sing, that's all good, but you can close it. You don't have to open it, you can close it. And you can keep it closed and you still have the fresh air available. So on a very hot day or on a very cold day, you can just keep your windows closed, keep the warmth inside and still have the fresh air that you need to live healthily in your indoor environment. Air quality traps are that our kids' rooms are often have high level of toxicants, that our window ventilation is not very practical, as I've just said, and that our bushfire smoke needs a HEPA filter. So if you're living in an area like that, you want to look into that. So Passivhaus really is asking for the minimum to maintain a healthy indoor environment. If we do less, we stumble. So this is what we really should do. Look at your indoor air quality. Ask yourself, what is the air quality in my home? And get a look at that, or look into the Passivhaus standard where all of that is really well looked after. So thank you very much for listening to me, for listening to why I think that indoor air quality is such an important part and such an important topic to talk about. I hope you learned something. I hope it resonated with you, and I see you in my next post.